Hello everyone. By now we have done basics of trigonometry and some formulae we have done in our last session. Now some of you must be really happy to see some formulae there. And I mentioned there that we will be taking minimum formulae required. And in that continuation, today in this session, now we will be having some more formulae. And as name suggests, the first one is factorization and defactorization. These names are not new to you. So I start with first defactorization formula. And I write first one as 2 sine A cos B equal to sine A plus B plus sine A minus B. Now if you look at right hand side, sine A plus B formula is known to you. That is sine A cos B plus cos A sin B. And sine A minus B, you have written that somewhere. It is sine A cos B minus cos A sin B. Now if you add those two, then plus cos A sin B and minus cos A sin B, that will get cancelled. And sine A cos B term will come twice. And hence, the left hand side is 2 sine A cos B. So 2 sine A cos B is sine A plus B plus sine A minus B. Now similarly, I can write 2 cos A sin B also. 2 cos A sin B is sine A plus B minus sine A minus B. Now what is the logic? That sine A cos B term I want to remove or eliminate, and hence I subtract sine A minus B from the formula of sine A plus B, and there I will get 2 cos A sin B. Now, I'm sure you must be waiting for what? Now cos formula. And I will see 2 cos A cos B I can have if I add cos A plus B and cos A minus B. Why? Because that plus sine A sin B and minus sine A sin B will get cancelled, and you will have 2 cos A cos B. Now, if I want to have sine A sin B term, like that term to survive, then I will have to subtract. Now see that carefully. Cos A plus B you will have to subtract, not cos A minus B. Cos A plus B, if I subtract from cos A minus B, that means cos A minus B is cos A cos B plus sin A sin B. And cos A plus B would be cos A cos B minus sin A sin B. So minus cos A plus B will give you that minus of minus sin A sin B, and hence you will get two terms of sin A sin B. So 2 sin A sin B is cos A minus B minus cos A plus B. This is the only formula where students at times get confused. But rest three are very, very straightforward. Actually here also only that order you have to remember. Otherwise nothing special about it. Now why do we call it as defactorization formula? See the left hand sides. They were appearing as product of two terms. And whenever you write product in terms of sum or a difference, that is called defactorization. So these four formulae are called defactorization formulae. Now I want to use these four formulae for next set of formulae. Before I go there, how many of you have understood that actually the originally the parent one were just sine A plus B and cos A plus B. We derived sine A minus B and cos A minus B from there. And from sine A plus B, cos A plus B, sine A minus B and cos A minus B. We have found these four. That is defactorization formula. I go to next. And now I make some changes here. I replace A plus B by C and A minus B by D. Now that means those right hand sides wherever A plus B and A minus B are occurring, they are going to go in terms of C and D. Now don't you think even on left hand side I will have to write in terms of C and D. And for that, I will need separately A in terms of C and D and B in terms of C and D. And hence, I use that A plus B equal to C and A minus B equal to D. If I add those two, means C plus D will take me to 2A. And hence, A would be C plus D by 2. And if I subtract, I will get B equal to C minus D by 2. And now rewrite these four formulae. And that will give me nothing but factorization formula. And sin C plus sin D, that is the right hand side of the first formula. Sin C plus sin D equal to 2 sin. Now what is that C plus D by 2? That C plus D by 2 is nothing but A. So in place of 2 sin A cos B, in place of A you write C plus D by 2. In place of B you write C minus D by 2. So you get the first factorization formula. Sin C plus sin D equal to 2 sin C plus D by 2 cos C minus D by 2. Now similar thing we will be writing in remaining three also. And I get sin C minus sin D exactly on similar lines. So 2 cos C plus D by 2 sin C minus D by 2. Now next would be cos C plus cos D equal to 2 cos C plus D by 2 cos C minus D by 2. And the last one would be cos C minus cos D. Mind you please, if you look up in the fourth formula, that is actually cos D minus cos C. But I am writing now as cos C minus cos D. That means one negative sign I will have to adjust on the right hand side. And that I have adjusted in the angle D minus C. If you can see that carefully, you will understand what I am saying. Right hand side is 2 sine C plus D by 2 and sine D minus C by 2 I have made. Those who do not want that D minus C by 2 to occur there, they can write minus sign outside and they may write it as minus times 2 sine C plus D by 2 sine C minus D by 2. But I generally write sine D minus C by 2. So I have written here also D minus C by 2. If you wish, you can write minus sign outside and inside in the angle you will write C minus D by 2. So these are factorization formulae. Why do we call them factorization formulae? Have you realized? Sine C plus sine D, it was sum of two sine terms. And then I am writing it as a product whenever sum of two quantities or difference of two quantities is written as product, then it is called factorization. This you have already done in your previous classes. So these four formulae come under the category factorization formulae. Mind you please, all 8 formulae have been obtained from basic sine A plus B and cos A plus B formula. This is one thing. And before I proceed, I would take your attention to one small thing. Remember one thing, that I can never have sine A plus B plus cos A minus B kind of. Either both sine terms come together or both cos terms come together. And then revisit these formulae and understand what I am saying. Now I proceed further and then we will be going for multiple angles or half angle formula. What I mean by multiple angle? It could be 2A, 3A, that kind of angle I would be calling as multiple angle. So first is multiple angle. Sine 2A is 2 sine A cos A. How I must have derived this? Sine 2A means sine of A plus A. Use formula sine A plus B. And get this, you will have sine A cos A plus sine A cos A. And that is nothing but 2 sine A cos A. Is that okay? Should I move to next? That is cos 2A. Cos 2A again, replace B by A in formula of cos A plus B. And you will get cos A into cos A minus sine A into sine A. And that is nothing but cos square A minus sine square A. Now, someone may feel that I do not want cos term there. Then fine, you can replace cos square A by 1 minus sine square A. Those who do not want sine term to appear there, they can write sine square A as 1 minus cos square A. So I can rewrite that cos 2A in two different forms other than these. 2 cos square A minus 1 and 1 minus 2 sine square A. So cos 2A can be written in 3 different ways. One is cos square A minus sine square A. Second is 2 cos square A minus 1. And third is 1 minus 2 sine square A. Now let me move to tan 2A. See, what I am doing is, I am just taking sine, cos, tan every day. I am not touching cosec, sec and cot. They can be taken as reciprocals. Now what about tan 2A? Tan 2A means tan of A plus A. Use formula of tan A plus B and arrive at 2 tan A upon 1 minus tan square A. Now these are sine, cos and tan of angle 2A. Mind you please, you must understand order of operation. If you are saying somewhere sine 2A, means first you are taking double of the angle and then applying sine. Many students misunderstand this as 2 sine A. No, 2 sine A means what? You first take sine and then take double of that, means multiply by 2. 2 sine A and sine 2A, they are not same. I hope you understand what I am saying. Order of operation is important. This is what I want to emphasize upon. Now next would be of 3A. Sine 3A, cos 3A and tan 3A. Now mind you please, sine 3A, though I have written straight away 3 sine A minus 4 sine cube A, you will have to take paper pencil. Write in place of B 2A. Use formula of sine A plus B. Simplify, within 2 or 3 steps, you will arrive at 3 sine A minus 4 sine cube A. If anywhere cos square term comes, replace that by 1 minus sine square A in the simplification. And that finally leads to 3 sine A minus 4 sine cube A. Cos 3A. Similar logic, replace B by 2a in formula of cos a plus b. If anywhere sine square a term comes, write it as 1 minus cos square a, because I want everything to come in terms of cos. So it leads to 4 cos cube a minus 3 cos a. Now one more, tan 3a. Tan 3a is 3 tan a minus tan cube a upon 1 minus 3 tan square a. If you want, from tan 3a, I can say same thing about sin 3a and cos 3a also. We have seen formula for sin a plus b plus c, cos a plus b plus c, and tan a plus b plus c. In place of b and c, you can replace a. That also will lead to 3a formula. So tan 3a comes as 3 tan a minus tan cube a upon 1 minus 3 tan square a. So now I have given you 6 formulae. One set of 3 formulae for 2a and then their trigonometric ratios. And then other is of 3a and again their trigonometric ratios. I proceed further and then I go for now half angle. So sum multiples we call. Sine square a by 2. Actually sine square a by 2 could have been written, I mean that sine square a by 2 equal to 1 minus cos a whole divided by 2 could have been written as 2 sine square a by 2 equal to 1 minus cos a. If you wish, you can do that way also. Realize this, that is nothing but formula of cos 2a where you are replacing a by 2. So sine square a by 2 can be obtained from that cos 2a formula. And similarly, if I wish, I can find sine a replacing a by 2 in sine 2a formula. I get answer for sine a as 2 sine a by 2 cos a by 2, which is very much visible from comparison of the two formula. Cos square a by 2, again, even that has been generated from cos 2a formula only. Write 2 cos square a minus 1 equal to cos 2a. Replace a by a upon 2 and you will arrive at cos square a by 2 equal to 1 plus cos a whole divided by 2. And one more, tan square a by 2 equal to 1 minus cos a upon 1 plus cos a. Actually, that is nothing but division of sine square a by 2 by cos square a by 2. And that leads to 1 minus cos a upon 1 plus cos a. Now, this set of formula also will have to be remembered with the previous session's formula. Now, let me take some identities which you can take them as, formula. The first one is sine 2a and cos 2a in terms of tan a. Sine 2a is 2 tan a upon 1 plus tan square a. And cos 2a is 1 minus tan square a upon 1 plus tan square a. These identities have become now formulae. Everyone uses them as formulae only. So, from examination point of view, it is better you also remember them as formulae. Now, there are two. I have written first one as sine square a minus sine square b. And that is sine a plus b into sine a minus b. And similarly, cos square b minus cos square a. That is also sine a plus b into sine a minus b. Remember one thing, both are actually one and the same. Sine square a if you write as 1 minus cos square a, and sine square b if you write as 1 minus cos square b, the second one you can obtain. And that is cos square b minus cos square a. Now, some of you may think that is it that we are using x square minus y square equal to x plus y, x minus y? No. You write sine a plus b formula, you write sine a minus b formula in two different brackets and multiply term by term, and then make sure that no cos term comes. Wherever cos square a term comes, you write it as 1 minus sine square a type, and then simplify. It will lead to sine square a minus sine square b. Correct? And from there, I go to next one, and that is tan a plus tan b upon tan a minus tan b equal to sine a plus b upon sine a minus b. Mind you, please, this identity, whenever you want to jump from tan to sine, is extremely useful. So I have given at this place only, and make sure that you also remember it. And one more before I leave from here. It is a sin x plus b cos x always lies between minus under root a square plus b square and plus under root a square plus b square. This property would be extremely useful when you go for problem solving sessions. So please, I request, remember all these formulae. When you meet me next time, you will be ready with all the formulae and all the theory, and then perhaps we will be in position to solve problems. Till then, stay tuned. Thank you.